All right, so here is page 6 for Unit 6. We're going to learn how to divide rational expressions, which is basically multiplied by the reciprocal. So when you have something like this, let's say you have a over b, and you're dividing it by, let's say, c over d, this is the same thing as you keep the first one, so you do a over b, change the division to a multiplication, and then we're going to flip the second rational expression. So this would be d over c. Okay? So here is a rational expression. So we have 5a squared divided by 10 over 10, which is divided by 6a over 3. Now, what we're going to do is we're going to keep the first one before I do anything else. I'm just going to set this up. So 5a squared over 10, change the division to a multiplication, and we're going to flip the second one. 3 over 6a, they're the reciprocal. And then now you have two options like you always do. You can either multiply straight across and then simplify later, or you can simplify first and then multiply. I recommend simplifying first, but again, it's really up to you. So if I were to simplify this, so I can do 5 goes into 5 once and 5 goes into 10 twice. And then 3 goes into 3 once and 3 goes into 6 twice. And then I can also reduce the a's. So if there's an a in the denominator and a in the numerator, you just have one a left. And then now you can multiply straight across. So you have a in the numerator, and then 2 times 2 is 4 in the denominator. Okay? Or if you want, we could multiply straight across first and then simplify later. Okay, so here's another problem. So I'm going to keep the first one. So you have x plus 8 over 8x. And then we're going to change it to a multiplication, and then we're going to flip the second one. And then now I'm going to simplify by canceling out the correct factors in numerator and denominator. See, at this point I couldn't cancel them out because it wasn't, but now technically because of the division, it actually goes in the denominator. I can go ahead and cancel out the x. I cannot cancel out these two x's because this x has a -3 attached to it, but these ones, they have the, you have a subtraction sign here, but these are all just being multiplied. So take out it. 8 goes into 8 once, and 8 goes into 24 3 times. So if I were to multiply this out in the numerator, I just have 3, and in the denominator, I just have x minus 3. Okay. Number 3. So again, I'm going to keep the first one. So you have, if you want to, like maybe just if I don't have to write it out, I know that I can change this into a multiplication sign by flipping these two. Okay, I can put x minus 2 in the numerator, and then what was that? X plus 6 in the denominator. So I don't have to write it out. Now that I have it like this, let me just, okay, I rewrote it by flipping them. Now I can go ahead and cancel these two out. I can cancel these two out, and then what do I have left? I just have in my numerator, I just have x minus 2 and nothing in the denominator, so which means that I don't really need to have this fraction bar. So all of this equals that. And then for number 4, this is also a division problem because you have, well, let me just tell you something first. So this is called a complex fraction. A complex fraction is basically when you have a fraction bar, and then you have a numerator and denominator. In the numerator, you have another fraction. Let's say a over b, and in the denominator, you have another fraction, c over d. So the way this works out is you can take the numerator, keep the numerator, basically it's the first term, the way it is, and then change it into multiplication by flipping the denominator. So you can do d over c.
Mom, your phone is...
Okay, so d over c, and then you can multiply straight across. So same type of thing here. So I'm going to keep the numerator, this numerator which has a fraction. So you do x plus 5 over 4x, and then here's your main fraction bar, so I'm going to change that into multiplication, and I'm going to flip the denominators. And over here I have 12x cubed, and then over here I have all of this, x plus 5, x plus 1. Okay, and then now I can simplify this. So it looks like I can do these two. I can take out the x plus 5 and x plus 5. And then you have here 4 goes into 4 once, 4 goes into 12 3 times. And then look at this, there's an x here and an x cubed here. So I can take out an x here, take out an x here, so I have x squared left. So let me put it all back together. So in the numerator, I have 3x squared, and the denominator I have x plus 1. And I cannot cancel these, sorry about that. I cannot cancel these x's because this x right here has a 1 attached to it. It's being added to it. Well, why won't it focus? Okay, so that's my answer. So this simplifies to this over here. Now, let me just, when it gets to complex fraction, you should probably go ahead and check your, hold on, let me pause it. Okay, so what you can do here is you can go ahead and check in Desmos to see if these two actually match. So we can go ahead and graph both of these expressions and see if they have the same graph. Now, when you're graphing a complex fraction, what I do is I do a division symbol, so I have a numerator and a denominator. And in my numerator here, I have another fraction bar, so I'm going to put another fraction bar. So here I have x plus 5, and then here I have 4x. And then in the main denominator here, I'm going to plug this in. So there's another fraction bar. And then you have here x plus 5, and then x plus 1. And then in the denominator, you have 12x cubed. Okay, look at how weird this graph is. Okay, anyway, let me go ahead and graph the other one. So which is 3x squared. This one is not a complex fraction, right? It just is one fraction, so I'm going to get one fraction bar. So you have 3x squared, and then you have x plus 1, and hopefully it's the same exact graph. The graphs it so fast, you might not have seen it change the color. See? It's the same exact graph. So that's correct. Okay, so that's one way you can check your graphs. All right, number 5. Okay, so this is also a complex fraction. The only difference is you have a numerator right here, which has a fraction. The denominator does not have a fraction, but I can always make it a fraction by putting a 1 underneath. So there you go. So there's my complex fraction right there. So I'm going to keep the numerator the way it is. So this is equal to, keep the numerator. So that is just x squared minus x minus 20 over x plus 4. Change the division to a multiplication, and we're going to flip the denominator. So 1 over x squared minus 25. Okay. Now to solve, or not solve, sorry, to simplify this, I cannot take anything out because it's not in factored form. Like for example, when you know it's in factored form is when you have parentheses. But here nothing is written in parentheses, so I'm gonna have to factor this, then I'm gonna have to factor this, then cancel out my common factors from numerator and denominator. All right, so we have here, let's do the first one. So this is, can factor out to, so you have x, and then you have x, you have to get a negative, so one has to be positive, one has to be negative, and then this has to be a negative 1, so I can do negative 5 times 4. Okay, which 4 times negative 5 is negative 20. 4 plus negative 5 is negative 1. So that looks good. And I'm going to bring this down. Times 1 over. Okay, so this one, I can use differences of square because I can rewrite 25. I can rewrite 25 as 5 squared. So I can use the differences of square formula from unit 2. So this would end up being x plus 5 and then x minus 5. Okay, look at unit 2 to do, how did I do? This is called difference of squares. Okay, so basically when you have something like this, when you have a squared minus b squared, you can use this pattern. So you have a plus b and then a minus b. Okay, so that's how I did this. So you have x and then 5. So this is x plus 5. X plus 5 and x minus 5. All right, so now I should be able to cross out the same factors. Oops, that's not the one I want to cross out. I want to be able to cross out x minus 5. So all of this equals 1 over x plus 5. Okay, so you can also check these two to see if they equal each other in Desmos. You can try it, but I'm gonna go ahead and move on. All right, so here again I have a division, so I'm gonna go ahead and keep the first one, change it to multiplication, and then flip this one. So I'm going to keep the first one, and before I keep the first one, okay, let me just go ahead and factor it out because I know I need to have it in factored form. So I'm just going to do this. So you have n, and then you have n, and then so this would be 3 times 2. Because 3 times 2 is 6, 3 plus 2 is 5. And then here, I can also factor this out because there's a common factor between those. So I'm going to factor out a 2. So when you factor out a 2, you're just dividing it. So that would be n plus 4 divided by 2 is 2. Okay. Change this into a multiplication problem. And then now we can go ahead and flip these. So you have here 5, and then you have n plus 3. All right, now I can go ahead and cancel these two factors. Cancel these two factors. I don't know why this is so satisfying whenever I cancel these. So you have now 5 over 2. This will be an easy one to check in Desmos because I only have to basically do one equation. So like if I do here, so I'm going to do division. And so you have n squared plus 5n plus 6 over 2n plus 4. So it's asking me to add a slider. I will do that. And then look what happens in Desmos when I put in a division symbol. So I'm going to put division. It throws everything in the numerator, which is fine. That's exactly what it is. Now I'm not going to flip this. I'm just going to put it exactly as my original problem was. N plus 3 divided by, see, that's why you need to make sure to put your division symbol first. N plus 3 over 5. Add the slider. I mean, it naturally turns it into a 1, but I mean, even when you change it, it still goes to 2.5, and 2.5 in fraction form is 5 over 2. Okay, so that checks out. All right. I'm going to go to this next set of problems that we have here, where we're going to look at practice finding equivalent expressions. So when we're looking for equivalent expressions, I mean, we can, you know, this is a multiplication problem, division problem, this is just simplifying, and this is a complex. Since it's a multiple choice, you could just plug it in and then plug these in and see which one matches your answer, right? So I'm going to show you both ways, okay? For the first one, let's go ahead. Well, here, let me just show you in Desmos how to do these problems, because it'll probably be faster this way. So here, I'm going to go ahead and plug in this problem. So you have here, put your division. So you have 3x minus 9. Sorry, I gotta go turn off the oven 1 second. And then you have x minus 9. And then x plus 1. I feel like this would be faster by just doing it by hand. X plus 9, x plus 1, and you have 9x plus 9. Okay, so what I have here is this graph. Okay, looks like it should just come out to some kind of a decimal. So it looks like it's either, well, it's not 3, because it's not crossing it at x equals 3. I think it is 1 over 3. Okay. Okay, 1 over 3, which is exactly where it's crossing it in Desmos. Yeah, 1 over 3, 3, 3. Okay, so that's where, so it would be answer choice A. Since this is in factored form, let's go ahead and check our answer by doing it how we learned. You can cross those out. You can cross those out. Cross that out. And so you have here 3 over 9, which reduces, 3 goes into 3 once, 3 goes into 9 3 times, so 1 over 3. Okay. Over here, now I'm going to go ahead and do this by hand, and then I'll go ahead and check it in Desmos as well. Okay. So here, I'm going to keep the first one, change it into a multiplication sign, and then we're going to flip the next one. Okay. So this would be 2v plus 3 in the numerator. This would be 9. Okay, now I can see if I can, okay, I can cancel these two out. I can cancel out the 9s. And so I have here v minus 4. You guys were probably waiting for that thing to break. V minus 4 over v minus 1. Oh, yeah, there's a 2 here. 2 there. So it's B. Okay. Or, you know, you can graph it in Desmos and then find it as well. See which one is the same. right, number 3, this is not factored out, so we would have to factor these two out. So this is a good example. Since it's a multiple choice, you can try it in Desmos and see if which one matches. So you can go to Desmos, you're going to put x squared minus 4 over x squared minus 3x minus 10. And so I'm going to press this home button. So here's my graph. And then now I can just graph each answer choice in my second one and see which one matches the graph. So you have x minus 5, x minus 2. That's not it. It's two different graphs. Maybe it's x minus 2 over x minus 5. Yep, that's the one right there. Okay. Let me go ahead and, oops. All right, let me go ahead and, yeah, so if I were to do this by hand, we know that this is a difference of square because I can rewrite 4 as 2 squared. So this would be x plus 2, x minus 2 over, and if I were to factor this out, plus and a minus, so that would be what? 5 times 2. Okay, so those cancel out, and there you go. X minus 2 over x plus minus 5. This one, I'm going to go ahead and try it in Desmos first. Okay. Alright, so this is a complex fraction, so I'm going to go ahead and put this fraction bar in here. And in the numerator I have this fraction bar, so I'm going to just hit another fraction bar. And then the denominator, the main denominator, I have another fraction bar, okay? So you have your main fraction bar, and then you have a fraction and another fraction. You're probably like, stop saying fraction. Well, sorry. X squared plus 13x plus 42, and then 3x, 2x plus 14 over 3x. Okay, so there's my graph, and then now I'm going to see which one. So it's not 2, because if it was 2, then it would be like a vertical line at 2, or yeah. And then over here, let me graph this. So you have x plus 7 over x plus 6. That's not it. Oops. Answer choice C, x plus 6 over 2. Yep, that's it. See? It happens so fast. There it is. So answer choice is C. If you're thinking, I hope she doesn't do this one by hand, I am gonna do this by hand. So I'm gonna take this and keep it in the numerator, and before I bring it over, I'm gonna go ahead and factor this out over 3x. So this is x, and then this is, let's do 7 times 6 is 42, 7 plus 6 is 3x. Change this division to a multiplication, and then we're going to flip this. So you're going to have the 3x in the numerator, and then over here I can go ahead and factor out a common factor, greatest common factor. So 2 comes out of this. So I have 2 parentheses x plus 7. Okay, and then now cross these out. I don't know, I just love crossing these out. And then so you have x plus 6 over 2, which is my answer. Okay, I'm done. Thanks, guys.